Linear motion, also called translational motion, is the movement of an object along a straight line. It is one of the simplest forms of motion and can be described using basic physical quantities such as displacement, velocity, acceleration, and time. In linear motion, all points of the object move in the same direction and cover the same distances in the same time intervals. The study of linear motions forms the basis of classical mechanics and provides an understanding of how objects move under the influence of forces. In this experiment, the concepts of position, velocity, and acceleration are analyzed to determine the relationship between these quantities and how they describe the motion of an object. Understanding the principles of linear motion is critical for a variety of applications, from predicting the motion of vehicles and projectiles to designing items where precise control of motion is required. The aim of this experiment is to investigate and measure the fundamental parameters of linear motion and to understand their interdependence in real-world scenarios. In this experiment, the objectives are to investigate the relationship between force, mass, and acceleration. The second objective is to determine the acceleration of an object under a varying force.
The apparatus needed for the experiment are a pulley, photo gate, mass hanger attached with a pressure tube by a spring, a blower, timer, a track rail and the flag, and the glider. For the procedure, the linear air track set is to be assembled as shown in the video. The pump is switched on and the air is allowed to flow through the track for several minutes. The track is balanced by adjusting the screw on its leg, so the glider remains stationary and does not glide to the either end when released. Hook is inserted at one end and the flag is placed on top of the glider. And then the mass of the hanger and the glider is measured and recorded, along with the length of the flag. One end of the string is attached to the hanger and other end to the glider. Mass of the 20 grams are placed on the hanger and 80 grams on the glider. The string is passed over the pulley. Afterward, the glider is positioned exactly before the photo gate. It is then released and the time shown on the photo gate is recorded. The glider is caught by hand before the hanger reaches the floor to prevent masses from scattering. After that, the procedure is repeated 2 more times to obtain the time average value. The slotted mass on the glider is decreased by transferring a mass of 20 grams onto the hanger, and steps 7 and 8 are repeated. The procedure is repeated on the 3 more times with 20 grams transferred from the slotted mass on the glider to the hanger.
This is result for experiment 4.
The graph tells us that the inconsistency of data due to it being caused by the experimental conditions. A qualitative trend by plotting a graph of weight, force, Fn versus acceleration A shows the quantitative data is not obtained correctly. The gradient of the graph is 0.10. This of the gradient of the graph is when we find that the maximum gradient is equal to 0.10 and the minimum gradient is equal to 0.10, and we divide it and we can get 0.10 for the uncertainties. Relationship between the gradient m from the graph and the total mass mt is that the gradient represents 1 over the total mass. By using Newton's second law, friction and air resistance will cause changes in the gradient of the graph, resulting it in a smaller value. Hence, the external force do influence the motion of the object. The percentage difference in question 1. Firstly, we need to find the average, which is equal to gradient plus total mass divided by 2. So 0.10 plus 0.29 divided by 2 equal to 0.195. Then we need to find the absolute difference, which is gradient minus total mass, equal to 10.10 minus 0.29 equal to 0.95. Thirdly, in order to find the percentage difference, we need to divide 0.19 and 0.195 times with 100 equal to 97.44%.
There are several factors that contributed to the errors in this experiment, such as friction between the glider and the air track, and also air resistance. Secondly, air track alignment that is not perfectly set up, causing additional forces. And lastly, systematic errors in photogate will influence measuring time intervals. For question 3, ways to overcome the factors mentioned in question 2 is by make sure that the alignment of equipment is in good and in a proper condition, and multiple trials is needed to get a better result to increase the accuracy and precision of each result stack.
Newton's second law of motion, which states that the net force acting on an object is directly proportional to the rate of change of momentum, or in simple terms, the object's acceleration. In both magnitude and duration, through the experiment conduct, it was observed that as the wake force increased, the object acceleration also increased proportionally, further validating Newton's second law. However, error were encountered during the experiment. Random error, such as fluctuation in readings or misinterpretation of photogate result, occur and were addressed by repeating measurement and carefully cross-checking the data. Systematic error, on the other hand, arose due to improper calibration of instrument or incorrect blower setting, which were resolved by careful calibration and adjusting the experimental settings to optimal level. Overall, the finding confirmed the relationship between force and acceleration, as stated in Newton's second law, while emphasizing the importance of minimizing error to obtain more accurate and reliable results.
Conclusion for the experiment is, this experiment successfully validates Newton's second law of motion, which states that the force acting on an object is directly proportional to the acceleration of the object, with the mass being constant. Using a linear A track, the relationship between force, mass, and acceleration was investigated. The acceleration of an object increases proportionally as the net force applied increases. For a given force, heavier objects exhibit slower acceleration, while lighter objects accelerate faster, as per the equation F equal to ma.